Hey guys, Paul, Inventor 3 here. um, let's see, we're going to talk about the wireless power transfer and some other points here that I have written on this piece of paper I'm going to show you in a second. I've been studying in the areas of electricity for 18 years. I get excited every time I hear the word phenomenon. You know, basically that's an observed event. It means when we put A and B together, we know it equals C. We'll even make it a law. It's a law. We know this happened. We put A and B together, but we might not know or understand how or why. Now, when you understand that how and why, then you got complete control over it. But anyhow, so my specialty is electricity. I also like the phenomenons. I study in phenomenons. I'm like a fringe scientist too. There's areas of the government and the corporation just kind of put on the side. This device is only going to make us 100% profit. We're looking for 1,000% profit. That's garbage. You know, let's forget about that. You know, so there's a lot of things throughout history that have been forgotten, and it's hard for me to accept that today, after 150 years, we're still generating electricity the same feeble, weak way. And that's my opinion. It's feeble and weak, but it is. All right, so anyhow, let's carry on here. But this is what we're going to talk about today. And resonance, open circuit, high frequency, and voltage. Now, all these things are existing in my system that I use today. Resonance. Now you might want to mark these down. Resonance was the first one that I learned about and how important that was. Nikola Tesla, John Hutchison effects. It's talking about phenomenons. This is one of the places that you're going to see phenomenon attached to more than anything. At least I have. Whenever anything resonates, there's usually, not all the time, there's usually phenomenons associated with it. So that's why this really gets my interest. Now Tesla, he resonated things. Resonance is timing. You got to get timing right. It's like the best way to describe it is pushing a swing. And I don't know if you've ever seen like a baby swing that you put an infant in. In my days, it used to be a large crank-up thing with the big spring coil in there. Nowadays, it puts 4 D-sized battery and it just goes pop. It taps the swing. Pop. Taps the swing. Taps it just the right time. And that's resonance. When you tap it just the right time, you're building up this energy. So resonance is extremely important. Next thing is open circuits. Open circuit, well, basically wireless transfer of energy. Okay, you're it's open. There's, this is another thing. When I'm working with, when I read about wireless power transfer, it's not always in resonance. Okay, they could do it without resonance. It could be capacitance, resonance, capacitance coupling, or resonance, inductive coupling. But anyhow, when you do have a wireless system that is in resonance, there's between 10 and 30 times more power transfer. Okay, open circuit. You definitely don't want my circuit, guys, is not, and I thought it's not even a loop. It's a straight line. The other thing you gotta think about with open circuit and a no load situation is, you got to think about back in the 1800s when we had radio and people had crystal radios. There were no batteries. Okay, these picked up the energy from the radio tower to power the radio itself. And it's funny, for years I thought about this, and it's like, well, I never got a straight answer. Well, it don't matter now. I said, what is the difference if you had, 10 people tuning in to that station or 1 million people tuning into that station? They're all receiving that power, that energy. It's not like that radio tower gets bogged down. It's not like during the summertime when everybody's running their air conditioners and the power plant starts bogging down and has to needs backup power. It's different with radio frequencies. You're emitting, you're radiating, moving from center outward in all directions. That, and now think about those 1 million people using that crystal radio, and think if all of them connected all their radios together. So anyhow, that's one of my points. Anyhow, high frequency. You want the skin effect. You want to be over at least, I forget what it is, 100 or 200 kilohertz. You want the skin effect. Okay, you want that energy to ride on the outside of that conductor, not through the middle. You know how much resistance all those subatomic particles are fighting their way through a sand lot, a sand pit there. They're bouncing right on the outside. It's virtually like a superconductor. There's very little resistance. And I've read through Tesla's writings, Morey's writing, and someone else 3 times now. They talk about, like, you got a wire, and instead of like the energy and everything going through the middle, it's going on the outside, and it's drawing energy from everything around it. So that's, you want high frequency. It's very important. Superconductivity, virtually no resistance. And what more can you say? I mean, voltage. Now, this is one of the last things I've learned. It's, don't worry about the current. It's all about that voltage. Voltage is what's going to create the current. And again, I'm trying to think of this. You'll get the current back in the end. Also makes me think of John Hutchison, high pulsing electrostatic fields. It excites these the electrons and subatomic particles, and it loosens them up, makes them more active, easier to give up their energy and their electrons. So that's about it, guys. I'm sure there's probably some points I'm missing yet, but that's about it. These 4 points are extremely important. So, till next time, guys. Everything's getting very interesting here. We'll see where we can go with this.